So in this problem, both tank and tube are open to the atmosphere, and L length of this pipe is given, it's 2.13 meter, and we are after this angle theta. So I start from this side, I define a point like point A up here, and then I define another point like point B up there. Obviously, pressure at point A is equal to atmospheric pressure, pressure at point B is also equal to atmospheric pressure. Then I move from point A until I get to point B. So the first thing is that I write pressure at point A, I move downward and I stop at the interface. Here I define point C. So I have point C here. Okay. So when I go from point A to point C, I'm going down, so pressure increases. I have the plus sign, it increases by gamma H. So I'm going down through oil, so it's gamma of oil multiplied by H of oil, which we know it's 0.5. So the value of this H is 0.5. I convert this to meter. So now I'm at point C and I'm at the interface, so I can define another point here like point C prime, and then we know that pressure at point C is equal to pressure at point C prime. So there is nothing that I can add here because I'm just going from point C, I'm jumping across to point C prime. And then I go up from point C prime all the way to point B, because if we're going up, then pressure decreases by minus, so I have this minus sign because I'm going up, gamma of water. The reason is that we're going up in water multiplied by H of water, and then this is equal to pressure at point B. So the point is finding H of water. How much is this H when we go from point C prime to point B? What's important is displacement in Z direction. So we are actually after this distance. This is H of water because this is displacement in Z direction when we go from point C prime to point B. To find this, what I do is I find this distance, the entire distance that we have here from point B, which is like L sine theta. So this is something that we know because the length of this pipe is L, the angle here is theta. So this distance here is L sine theta. And then we also know this distance, which is equal to this value that we have here, 50, and then I convert it to meter, so it's like 0.5. So from there, we know that this H of water is equal to L sine theta. This is equal to L sine theta minus 0.5. So, and we also know that pressure at point A, because it's open to atmosphere, is P atmosphere, and pressure at point B is also P atmosphere. So this is also P atmosphere. So these two pressures are equal and they cancel each other. So we are left with gamma of oil, and the SG specific gravity of oil is given, it's 0.8. So gamma of oil is actually 0.8 multiplied by gamma of water. And then H of oil, which is like 0.5 multiplied by 0.5 minus gamma of water. We have gamma of water times H water, which is L sine theta minus 0.5. So this times L sine theta minus 0.5 equal to 0. And then we can obviously cancel gamma of water with gamma of water. So we have 0.8 multiplied by 0.5, which is like 0.4, right? Minus L sine theta, and then we have plus 0.5 equal to 0. And then from here I can say 0.9 equals to L sine theta. Therefore, sine theta equals to 0.9 divided by L, and the value of L is given 2.13, so it's divided by 2.13. And from here, you can calculate theta as sine inverse 0.9 divided by 2.13, which is equal to 25 degrees.